Assalamualaikum. My name is Nuur, Kyraa, binti Zahari.
My name is Claire Siow.
My name is Ooi Yin Qian.
My name is Khosalya Shamugam.
My name is Zi Huan.
And today we'll be doing a backyard experiment called the fruit-based galvanic cell.
A galvanic cell converts chemical energy into electrical energy through a spontaneous redox reaction. In our experiment, acidic juice of fruits acts as the electrode, while the zinc nail and copper coin function as the electrodes. Zinc loses electrons through oxidation, and hydrogen ions gain electrons through reduction, producing an electrical current. This experiment will investigate the effect of fruit and vegetable electrodes on the cell potential. We hypothesize that more acidic fruits and vegetables will produce a higher voltage.
So the objectives of this experiment are to investigate how the pH of different fruits and vegetable electrolytes affects the voltage produced by a zinc hydrogen galvanic cell. We also aim to compare the experimental voltage measured with the theoretical cell potential calculated by the Nernst equation, and also evaluate the potential of the fruits and vegetables as an alternative source of electrical energy.
The apparatus used in this experiment is a knife, a multimeter with wires on both the positive and negative ends. We have crocodile clips and wires, 2 of them. We have a container and also pH paper with the color charts. And the materials used in this experiment is 5 copper coins and zinc nails. We also have 1 potato, 1 lemon, 1 tomato, 1 orange, and pickles.
Firstly, cut the orange into a thick slice by using a knife. Squeeze out the juice from the orange into a separate container. Dip the pH paper into the orange juice until fully soaked. Compare the color of the pH paper to the pH color chart and record the pH value. Insert the copper coin into one side of the orange about 1 to 3 cm deep. Insert the zinc nail into the other side of the orange about 1 to 3 cm deep. Using the connecting wires, connect the copper coin to the positive terminal while connecting the zinc nail to the negative terminal. Wait 60 seconds for the multimeter to stabilize, then record the observation into a table. Repeat steps 1 to 8 by replacing the orange with a water apple, lemon, potato, and a carrot.
Now I will explain about Nuur's equation and our expected results. The Nuur's equation is used to calculate the cell potential. In our actual experiment, the pickle was swapped for pink guava and the tomato was swapped for carrot. This is ensure that all fruits have different pH value. We have calculated the predicted a cell value using a voltage using the Nuur's equation, and these values are compared to the results from today's experiment. From highest acidity to lowest, lemon has measured voltage of 0.98, pink guava with 0.96, and orange with 0.94, carrot 0.93, and potato 0.88. What is the next trend shown from these results?
Based on our observation from this experiment, we identified that the trend is when the fruit is more acidic, the pH value will be lower. Hence, the voltage reading on the multimeter will be higher. But what is the reason behind all of this?
The factors that determine the voltage shown is the hydrogen ions of the fruit, which is reduced at the cathode. We can use the Le Chatelier principle and the half reaction at the cathode to explain the reasons behind the trend. At lower acidity, pH is higher. Thus, the concentration of hydrogen ions is lower. When the concentration of hydrogen ions is lower, the equilibrium shifts to the left, reducing the reduction potential and also the overall cell potential. Now, what is the difference between the predicted E cell value and the voltage that we have recorded today?
So the Nuur's predicted value is lower than the actual value that we measured today. The differences between our theoretical and experimental voltages can be explained by several sources of deviation. Firstly, the Nuur's equation assumes that ideal condition including a constant zinc ion concentration and accurate pH values. In reality, the zinc ion concentration changes as the reaction occurs, leading to differences between the predicted and measured cell potentials. So, what are the other sources of deviation that is present in a real life setting?
So first is the fruit electrolyte has internal resistance, causing some electrical energy to be lost as heat and also reduce the measured voltage. Second is the zinc nail and copper coin are not pure, so impurities can affect the results. Finally, the nails and coins are used for each fruits and vegetables are different, which may cause the pH of each fruit or vegetable to be not accurate.
To conclude, the hypotheses have been accepted. Higher acidity of fruits will result in higher voltage. In addition, the objective of this experiment have been achieved.